In 1969, Neil Armstrong took a giant leap for the mankind. But what if the next leap isn't just technological, but biological? What if centuries from now, humans evolve into a new species with denser bones, radiation-proof blood, and senses sharpened for the void? Today, we are diving into the science of how space will rewrite our biology and whether we will even recognize humanity's future form. In space, your body wages war against itself. Without gravity, bones lose 1 to 2% of their density every month. That's 10 times faster than osteoporosis on Earth. Astronauts return with a skeleton as fragile as an 80-year-old's. But why? Your bones are in a constant tug-of-war. Osteoblasts build bones, while osteoclasts break it down. On Earth, gravity keeps its balance. In space, osteoclasts go large, dissolving bone your body no longer thinks it needs. NASA's 2023 study tracked astronauts on 6-month ISS mission, losing 10% of their hip bone density, equivalent to a decade of aging. Radiation, the invisible killer. Earth's magnetic field shields us from deadly cosmic radiation. But in space, you are naked. A single solar flare could deliver a lethal dose. Even on Mars, radiation is 50 times higher than Earth. Over time, this shreds DNA, causing cancer, brain damage, and sterility. Imagine yourselves as a library. Cosmic rays are vandals tearing pages at random. NASA's asteroid vest, tested on Artemis I, uses polyethylene to block radiation, while startups like Microvolt engineer fungi that absorb gamma rays. Psychological stress, isolation, warps the mind. In NASA's HIC's Mars simulation, crews developed space madness like erratic sleep, paranoia, and hallucinations. Your brain evolved to crave sunlight, fresh air, and social bonds. In a cramped metal box millions of miles from Earth, those instincts turn against you. Future humans might evolve a smaller amygdala, the brain's fear center, or produce more oxytocin to strengthen social bonds. Imagine crews wired for cooperation, not conflict. To survive, future humans might shrink. Shorter bodies reduce bone and muscle strain in low gravity. Think of hobbit humans who evolve on an Indonesian island with scarce resources. Their small stature conserves energy. Similarly, astronauts could trade height for durability. In NASA's artificial gravity bed rest study, subjects in centrifuges mimicking Mars gravity retain 30% more bone density than those in zero. But evolution is slow. Genetic engineering could fast-track adaptations. Scientists have already identified the SAS gene, which regulates bone density. People with SAS mutation develop bones so dense they are nearly unbreakable. CRISPR technology could edit this gene into astronauts, creating self-repairing superbones. And for radiation resistance, we might borrow DNA from tardigrades, microscopic water bears that survive the vacuum of space by repairing their own DNA. Your heart isn't built for space. In microgravity, blood pools in your upper body, causing puffy-faced bird's leg syndrome. Over months, the heart weakens like a muscle you never use. Astronauts on the ISS lose 10 to 20% of their heart mass in 6 months. To adapt, future humans might evolve hearts shaped like a seal's compact and spherical to handle fluid shifts. Blood vessels could become hyperelastic, preventing fainting with moving between Mars gravity and a zero-G habitat. NASA's VLEO experiment tests centrifuges that simulate gravity, forcing the heart to work harder. Radiation turns your body into a time bomb. Cosmic rays fragment hemoglobin, causing anemia. What would be the solution? Borrow from extremophiles. The bacterium Deinococcus radiodurans survives 50,000 times the lethal human radiation dose by rapidly repairing its DNA. CRISPR technology could splice its repair genes into human stem cells, creating radiation-proof blood. And for low-oxygen Mars habitat, what we can do? Future humans might mimic Indian highlanders who survive at 30,000 feet with 20% more red blood cells. In space, your eyes literally flatten. Fluid shifts in zero-G pressurize the optic nerve, causing spaceflight-associated neuroocular syndrome, SANS. 60% of astronauts return with permanent vision loss. Future humans might evolve larger eyes with fluid-regulating membranes, like tarsiers, whose massive eyes dominate 70% of their skulls to see in the dark. And for Mars dust storms, a third eyelid, like Arctic reindeer, could shield against debris and radiation. Your inner ear is a gravity detector. In space, it's useless, leading to nausea and disorientations. Evolution might add backup systems, redundant otoliths, like fish that sense movement in 3D. And with no air to carry sound, hearing could shift to low frequencies. Imagine ears tuned to the hum of life support system, not human voices. Pregnancy in zero-G. Fetal development relies on gravity. Mouse embryos in simulated zero-G fail to form a skeleton. How to fix this? It would be the artificial wombs with centrifugal gravity, like those being prototyped by Spaceborne United, or gene-edited embryos programmed to grow bones without mechanical stress, a process called gravidity. Raising space babies. Child rearing in space would demand radical social shifts. High infant mortality might favor communal parenting, like bonobo societies. But is it ethical to birth children who can never visit Earth? As ethicist Dr. Maria Konovalenko argues, we would create a case of human forever exiled from their home planet. This isn't sci-fi. Labs today are forging humanity's space future. NASA's Galactic Cosmic Ray Simulator at Borhavan Lab bombards cells with radiation to test countermeasures. DARPA's BATS program enhanced soldiers' vision, the tech that could adapt astronauts' eyes for Mars. Startups like Ectolife are designing artificial wombs, while genomic prediction screens IVF embryos for space-resilient traits. This is the paradox of space adaptation. To leave Earth, we must become less human, denser bones, radiation-proof blood, eyes that see in the void. But how much we can change before we lose what makes us, us? Would you volunteer to birth the first child destined to never feel the sunlight, swim in an ocean, or breathe unfiltered air? Or is Earth's gravity written into our DNA? If you would risk floating pregnancy for science, smash like. If not, comment why.